Okay, there we go. Okay. Okay, now, starting right at the beginning. Yesterday we talked about slope. Slope. Oh, and I'm going to put today's date on here. We talked about slope as the tilt of a line. So you've got a positive slope, a negative slope. Horizontal lines have a zero slope. Vertical lines have, as strange as that is, an undefined slope. We talked about slope as being what you get when you use the slope formula. And we talked about slope as being rise over run. We talked a lot about slope. Well, today we're going to talk about slope as being the rate of change. How fast is something changing? And as you can imagine, in business and in science, how fast something is happening is very important, even for us. How fast are they going to get a vaccine for COVID-19? How fast are we going to get back to normal? We really care about rates of change. How long will it take to get to grandma's house? Those are all talking about rates. So rates are the slopes of straight lines, as we're about to see. Okay, here's a line. Maybe it's not the most interesting line in the world, but it's a line. And what this does is this line is the graph of the rise in the luxury purchases in some countries. In a certain country, it says with respect to time. And what that means is, what is the price as years go by? And they start out measuring in 2008. And then every year after 2008, all the way to 2015, how did the price of luxury goods change in, look at this, in billions of dollars in a particular country, which means they probably made up all the all the numbers. So this is going to give us dollars per year. Anytime you hear the word per, it's a rate. So we're trying to find the rate of change in billions of dollars per year. And we're going to use this chart to find it, because all we need is 2 points, and they actually give us 2 points. In 2008, the purchase of luxury goods in that country in billions of dollars could be measured by 8.1, which means $8.1 billion. And then by 2015, the price of those luxury goods has gone up to 27.2 in billions of dollars. Our job is to find out what is the change in billions of dollars per year. And here's how we're going to do it. I didn't mean to do that. Come back. Come back. There you are. All right, I just wanted that. Okay, now by playing around with these scroll bars, I'm going to be able to move to the data I need. But right now, we're going to look at the rise in the price, rise in price of luxury goods. From 2008 to 2015. So, in 2015 again, we have the point 2008 because the years are on the x-axis, that comes first, and then 8.1, meaning 8.1 billion. But since both prices are in billions, there's no reason to write all those zeros. Now this is one point, and the point at the other end is 2015, 27.2. Okay, now we have 2 points. That means using the slope formula is the perfect thing for us to do because of a secret. And now you know the secret, and that is that slope and rate of change, or just rate, are the same exact thing. So here we go. If I let this be x1 and y1, and this be x2 and y2, we're going to be able to do what we did yesterday and put this into the slope formula where we have y2 minus y1 over x2 minus x1. So we're going to have y2 minus y1 over over x2 minus x1. So here we go. 27.2 minus 8.1 over 2015 minus 2008. And let me make that a little bit bigger because I wrote too small. So now what I'm going to do is say 27.2 minus 8.1 over 2015 minus 2008. And I know that 2015 minus 2008 is 7. But I'm going to drag up my calculator, which is called the TI Smart View, and I have it free for 90 days. Then I'm going to have to pay, but I don't know yet what I'm going to have to pay. So it might just be too expensive or it might not, but I really like it a lot. It does a lot more than just this. Okay, so move this over. 27.2. Okay, you can back up and I can hit delete. Isn't that great? Okay, minus 8.1. And I'll hit enter. 27.2 minus 8.1 is 19.1. Okay, so that's all I needed it for. I could have done it by hand, but I'm worried about straining my poor brain. So we're going to have 19.1. Let me make sure that was really it. Yes, 19.1. Over 7. Well, wait a minute, come back here. I'm going to divide 19.1 now by 7. And now I have this, an ugly decimal. But that's okay, because the problem tells us that we need to type an integer or a decimal rounded to 2 decimal places as needed. Okay, cool. So here's my decimal, 2.72857. And what they want me to do is to round this to 2 decimal places. So here's the first decimal place, here's the second decimal place, here's the third decimal place, and the third decimal place controls whether I round the second decimal place up to 3 or just leave it as a 2. And this 8, because it's 5 or bigger, is big enough to round the 2 up to a 3, so my answer in MyMathLab is going to be 2.73, meaning 2.73 billion dollars per year. So for the past 7 years in this story, the rise in luxury purchases has been $2.73 billion every year. So it goes up by 2.73 on an average every year. And that's probably the most important thing today that we use slope for. Discussion. Any discussion?
Yeah, I typed in 2.73 and it's
okay, our numbers might not be exactly the same. Let me try.
no, it wants it in like slope form, I think.
Oh, heck, you're kidding me? No, it says round it to 2 decimal places.
Let me see if you get the same thing. Do.
I get an okay. That's because probably our numbers are a little bit different on your problem and my problem, and that will almost always be true.
Okay.
Sometimes the questions that we get are different from the ones that Miss Rademacher is going to be showing us.
Oh, okay. Yeah, I'm stupid. Never mind.
No, you're not. Don't say that.
Okay.
Okay, now we have another one. Look at this. We have a rate going down. Now let's see what this means. The value of a computer in hundreds of dollars. And these are the numbers of years on the bottom. Almost always years will be on the x-axis. And the money is on the y-axis. And what we have here is there's a particular computer and it cost in hundreds of dollars, my golly, $3,600 3 years ago. But now today, the price has gone down to $1,800. So what we need to track is what is the drop in the price per year. And we're going to do it by finding the slope. Okay. Okay, so in year 0, which was the beginning of the measurement, we're just going to say 36, but of course it really means 3,600. And then when it gets to today, the price is, at 3 years later, is $1,800 for the same computer. Okay, we are going to find the slope, and once we have the slope, we're going to find how fast and in what direction is the price changing. So we'll have X1 and Y1 and X2 and Y2. And all right, so M equals Y2 minus Y1 over X2 minus X1. And that's going to give us 18 minus 36 over 3 minus 0. So that'll be 18 minus 36 is negative 18. And 3 minus 0 is 3. So we will have the answer negative 6. And what that means is the rate is negative. The price is going down. Notice that the line is tilting in the opposite direction from the previous line. The previous line was going up like this, and this is going down. That's because the price is dropping. All right, so our rate is going to be not negative $6, but negative $600 per year. And by finding the slope, we found how fast the price is dropping. So sometimes rates are positive and sometimes rates are negative. Okay? Anyone want to discuss this? I'll put this in here and just make sure. How about negative 600? Yeah! I'll like it as long as it doesn't tell me I'm wrong. Okay, and here we are. And now get ready for something that's a little bit, but not a lot scary. It might be a lot scary. Slope by another name. Before I bring this up and everyone goes screaming and drops the class, let's remember that we did a few problems on evaluating functions. For instance, if you have a function like f of x equals 3x plus 2, and you evaluate it for suppose you want to know, well, okay, what is that going to equal when x is 6? So that would be, you put a 6 in here, in the parentheses, and what that is a code that, like a computer code, that tells you, okay, tells the computer, okay, computer, you've got to stick a 6 in here for the X. And the computer does that and gets 3 times 6 is 18, plus 2 is 20. And that's called evaluating. So now that we know that, it also ends up that I'm not stuck with numbers when I use function notation. I'm not stuck with numbers. I can put anything in here that I want. Like for instance, suppose for some weird reason, I wanted to put an asterisk in there. Well, then I would have f of asterisk. And, oh well, the code says whatever is in here, I have to put in here. And what that will give me, as strange as it seems, is, is that. So, I can even, let me pull this up here so you can see it. I can even do this. And this is what we used to say back in the 60s. Oh man, this is a trip. Okay, but that's not what you say now. Okay, here we go. I could put, and I'm just thinking about random things. I am thinking, and it really gives me a headache. Let me make sure I'm recording. I recorded, didn't I? Didn't I stop and record?
Yes.
Thank goodness. Okay. You all have to be my memory. Suppose that for reasons I don't know, I have to stick this into f of x equals 3x plus 2. Well, if it says to do it, I have to do it. I'm going to mute myself for a minute and be right back. Thank you. I didn't take my antihistamine this morning because I wasn't feeling sneezy. That will teach me. Okay, so I'm gonna, there we are, we're back at the math. Okay, so here I am, and I just have to do what the math says to do now. I'm going to multiply 3 times k and 3 times 6. So that will be 3k plus 18 plus 20, plus 2 because it's gonna be 20. This is going to be 3k plus 20. So f of k plus 6 equals that. And that might have a meaning in accounting or in engineering. You know, so it ends up being important. Maybe K is some really complicated decimal number. And rather than deal with having to write it every time, you just go ahead and say, well, let it equal K. Okay, now why are we doing this? Well, it's important because you're going to run into a different kind of slope. Okay? And now I'm going to turn on the homework. Let's see. The difference quotient. That's what it's called. And we're going to talk about it. So it's written real small right now. So let me make it larger. Maybe. Yeah, there we go. Whoa, come back. All right, all right. There, that's good now. And I'm going to bring back my writing tablet. And we're going to deal with this. The instructions say for the function f of x equals 9x plus 5, construct and simplify the difference quotient. And this is one formula you do not have to memorize because you'll see it every time there's a problem requiring the difference quotient. It is f of x plus h minus f of x over h. And this formula revolutionized the world. Think about some kind of curve. It's not a straight line. It just does curvy things. Now, what if you wanted a formula? Whoops. I hate the way I draw. It's not great, but oh well. I mean, I could have put a straight line in there, but I'm just not doing it. All right, pretend this is the x-axis. And that's the y-axis. No, that's too horrible for words. Now I'm going to put a couple of bars up there. All right, boom. Here we go. This is the y-axis. And this is the x-axis. And that feels so much better. Okay, now go back to my pen. As a business person, suppose that curve means something to you. And you need because this is what it's primarily used for, you need a magic formula that for whatever x represents, you could go to any x and find out how fast are prices changing at that point. Maybe x is years, and you want to be able to forecast if everything stays the same, which it never does, but that's what you have to assume. If everything stays the same, what will be the rate of change in, I don't know, 3 years? So I didn't draw it correctly. Let's come down here. I have to come direct here. Bah. All right, we're going to go there. At this point, which is just a little to the right of the highest point, how fast are prices changing at that point? If I can find the slope of that line, which I could do just by hand, if I could find the slope of that line, then I would know at that X what the rate of change in prices is. But then what if I wanted to know what they are at this X value? And at this X value? Because remember, it's years. So you've got better things to do with your life than go around drawing straight lines and then trying to figure out what the slope is. So this formula will do that for you. And whenever we work with straight lines, it's very, very easy. So this is the perfect time to introduce you to finding the difference quotient, which is just the slope of these lines. So you'd have to draw another line there, and you'd have to draw another line here, and it would be such a total pain. When I took economics, they made us do it that way. The professor handed out a bunch of rulers, and he said, draw these lines. We're going to do this by hand. And it made me appreciate the difference quotient. All right, so there are some steps because look, you've got three things that you have to know. You know what, there we are. We know what f of x is. That has to be given to you. You have to know what it is in advance. But we have to find f of x plus h. And then we have to subtract, like you've got subtraction up here. Well, I wish that would move, but never mind. And then the last thing we're going to do is divide by h. But we're going to find the answer at each different step. So if you do it this way, when the problems get harder, you'll be a lot less likely to make a mistake and more likely to get 100% on the problem. So step one. Step one. The first thing you're going to do is find what f of x plus h is. Now you already know that f of x is 9x plus 5? Yeah, plus 5. So wherever there's an x over here, I put an x plus h. So I'll have 9 times x plus h plus 5. Now at this point, you might be wondering what the heck is h? Tell you in a minute. I'm doing it because I'm thinking h. You have to watch out for that. Sometimes what you're thinking comes out and you didn't mean for it to. Okay, that's our f of x plus h. And what is h? H is a really small number. An example of a typical h would be 0.001. or smaller. 0.00001, a really eensy-teensy number. And rather than have to write that every single time, we just leave it H, because H could change. So what we're looking for when we do this is a formula that will, no matter what X is, let us find the rate of change. So 9X plus 9H plus 5. That's what f of x plus h is. Now, step 2. We have to find f of x plus h minus f of x. Because that's what the top of, the top of the difference quotient right there. I have to find what that is. So I know what f of x plus h is now, it's that. So I'm going to write that 9x plus 9h plus 5. And then I'm going to subtract. And then you must put what f of x is in parentheses, or terrible things will happen, and I'll tell you what. If you don't put the parentheses in, then you're going to say 9x plus 9h plus 5 minus 9x plus 5 is, all right, 9x minus 9x is 0, so you're going to have 9h plus 5 is plus 10. And you're going to get the wrong answer because that's not the answer. What you needed to do was put parentheses around here because you are subtracting the whole f of x, which is 9x plus 5. That means you're going to distribute the minus signs. If you don't have the parentheses there, you're going to forget to distribute both the minus sign to both terms. So now we have 9x plus 9h plus 5. Gee willikers. All right, I'm going to make that into a 5. Minus 9x minus 5. Now we have 9x minus 9x, and that is 0. We also have 5 minus 5, and that's 0. So what we're left with is just 9h. And that's what the second step equals. Okay. Now step 3. We put it all together. F of x plus h minus f of x over h is going to be, well, we worked it out. We found out that f of x plus h minus f of x is 9h. And then we're going to divide that by h. Which makes the h's cancel and leaves me with just a 9. The answer is 9. If you had not put your parentheses in at this stage, your answer would be 9 plus 10 over h. And that would be wrong. Now think about it. If the difference quotient, as ugly as it is just an overall formula that lets you find the slope no matter what, this is just a straight line. So you're going to have a line that looks like this. Well, in a minute, you're going to have a line that looks like this. And then you want to know for each x, what is the slope of this line? Well, it's a straight line. The slope is never going to change no matter what the x is. So of course the answer is going to be 9 when what you're dealing with is a straight line. The whole reason we're doing this is so that you know what the steps are to solving it, not to solving it, but to working it out. You know what the steps are when we get to the really hard problems. You're going to be much more self-confident. So, we're going to do it again. Okay, so, next problem. Again, it's going, oh, it's not a straight line. It's a, okay, that's harder. Let's see if the third one is a straight line. The fourth one is a straight line. For what? Oh, for that. Okay, I thought I had started out with just straight lines, but we're not. We're doing the real thing, gang. Aren't you excited? Okay. So we're doing the real thing. Now that you know the steps. Here's f of x. F of x equals x squared plus 8. And what that looks like is this. And for each x, you want to know what is the rate of change. You can look at it and see that, well, whatever this represents is going down until you get here, and then it's increasing as you go over here. But how do you know here what the rate of change is going to be for each x on the whole x-axis? You need a formula for that. So we're going to do this thing using those 3 steps. Step 1. Find f of x plus h. Well, what that means is x plus h, if you put it in for that x, is going to go in for that x squared. Okay, now this is where you can get fooled. Because everybody, including me, would love to be able to go x squared plus h squared plus 8. Ta-da! But that is so wrong. It's not true. The only time you can do that is if you have x and h multiplied and you square them. Then you're going to have x squared times h squared. But you can't do it when you're adding. So let me erase this. This is garbage right here. But it's a mistake every algebra student has made, always, almost every algebra student. Here's what you do. X plus h is a quantity, and it's being multiplied by itself. So, x plus h times x plus h plus 8. Oh, we got to put a little more work into this than before, because I am going to have to multiply these two binomials. And some of you learned this as foiling, and that's okay. Others of you learned it as a form of distribution, and that's the way I'm going to do it because that's the way we're supposed to do it now. So I take this x, and I multiply it by the second set of parentheses, and then I take the plus h, and I multiply that by the second set of parentheses. And then don't forget the plus 8, but it's out here not doing anything. Okay, now what I do is I distribute this x into x plus h, and then I distribute the h, the plus h, into x plus h, and I will get x squared plus hx, put the h first because it's a little number, plus hx plus h squared plus 8. And I'm not done, but I'm almost done. This is the first thing, this is the next step. We have now multiplied out x plus h times x plus h, and all we have to do is combine our like terms, and the only like terms we have are hx and hx. There are two of them now. So x squared plus 2hx plus h squared plus 8 is what f of x plus h equals. Now we go to the second step. Had to find my cursor there. Go to the second step, which is going to be f of x plus h, which we just found, minus f of x, which we already know. So let's do this. Here's f of x plus h. Minus parentheses x squared plus h. 8. I've gotten myself into a repeating loop now. Okay, so here's f of x plus h minus f of x. Okay, now I'm going to distribute the minus sign to the x squared and to the plus 8. So x squared plus 2hx plus h squared plus 8 minus x squared minus 8. Now that the parentheses are gone, we can combine the like terms. X squared minus x squared is 0. 8 minus 8 is 0. So what we're left with, let me mark through them to make sure I don't make a mistake. I'll be left with 2hx plus h squared, and that's the answer to step 2, f of x plus h minus f of x. After all that, that really doesn't look that bad. It could be worse. Okay, we're almost done. Third step. F of x plus h minus f of x. We know what that is. It's 2hx plus h squared over h means we divide by h. But if you remember your polynomial division, when you have multiple terms on the top and only one term on the bottom, what you do is you turn that into two fraction terms. H squared can also be written as h times h. I'm going to do that because you can see I'll be canceling. Here the h's cancel, and here one of the h's cancels. So our final answer, the difference quotient for, we need a drum roll, the difference quotient for x squared plus 8 is ba 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 ba. Okay, is 2x plus h. Ta-da! 2x plus h. And this allows h to expand and contract depending on what it needs to be for the calculation. Only the scientist or the economist would know what h really is. And h usually changes with time, or not. Most of the time, if you don't have a straight line that you're working with, if you've got anything other than a straight line, you're going to have an H, one or more H's in your answer. But with the problems we're doing today, you're only going to have one H in your answer. Let's do another one, and then I'll open it up for questions. Okay, there. 5 minus x squared. Okay, we're going to do the same thing, but now we're going to do it with 5 minus x squared. So we have f of x equals 5 minus x squared. And we're going to find the difference quotient. And I'm going to go through step 1, 2, and 3 again. But this is going to be a little dangerous because of that minus sign right there. F of x plus h is going to be 5 minus parentheses x plus h squared, which is going to be 5 minus x plus h times x plus h. Now, you are subtracting. Okay, so I need to put brackets around this. Remember back in pre-algebra, you learned that brackets are really, in this case, they're just another form of parentheses. They're just another way of grouping, but I have to protect the answers that I get. The answers that I get in here from that minus sign out there until I'm ready to distribute the minus sign. So this is going to be 5 minus, I'm going to have that x times x plus h plus and plus h times x plus h and then I distribute the x and I distribute the plus h. So I'll have 5 minus x squared plus hx plus hx plus h squared. Okay, notice that you always get, when you say x plus h times x plus h, one way or another, you're always going to get x squared plus hx plus hx plus h squared, which simplifies down to x squared plus 2hx plus h squared. Now, there is a formula for squaring a binomial, so you don't have to go to all this work. And if you know the formula, you can do that and save a step or two. But now I'm ready to distribute that minus sign. So I'll get 5 minus x squared minus 2hx minus h squared. And that is what f of x plus h equals. I have the hiccups. Okay. All right, what's the next step? The next step is not as difficult as that step. You have to be so careful in this step right here, because that's where most of your calculations take place. So now in step 3, I should have put a 2 up there. That was step 2. All right, step 3 is f of x plus h minus f of x. So first I'll write down what I know f of x plus h equals. It is 5 minus x squared minus 2hx minus h squared, and then I'm going to subtract and put parentheses around f of x, which is 5 minus x squared. And then I distribute the minus sign, so that what I have is 5 minus x squared minus 2hx minus h squared minus 5. And now I'm subtracting a negative, so that means I will add a positive like this. Okay, now that the parentheses are gone, I can combine like terms. 5 minus 5 is 0. And negative x squared plus x squared is 0. They zero each other out. So I'm left with negative 2hx minus h squared. And so now I know that f of x plus h minus f of x is negative 2hx minus h squared. Okay. Oh, that's not step 3. Wait. Emergency, emergency. This, where we just find f of x plus h, is step 1. Then we find f of x plus h minus f of x. That's step 2. Then 3 is the last step. Once we know what f of x plus h minus f of x is, we can put it all together. That's f of x plus h minus f of x. I put it over h. And then I make that into 2 separate fractions. And I'm able to cancel my h's out and cancel those h's out so that my answer, the formula for the difference quotient, is going to be negative 2x minus h. So you have survived 2 difference quotients. And you're better for it, says you. Okay, says me, but number 4 is that. So let's see if we can finish that in the time allotted. Because your homework, even though it won't be the same exact numbers, will be the same exact problems. So you want to make sure you can do this. Okay, so I have to scroll down to see what that is. Right there. We've got f of x equals negative 5x squared plus 6x plus 8. And so step 1 will be find f of x plus h. Now remember, whatever is in there, I have to put in all of the x's. So this will be negative 5 times x plus h squared plus 6 times x plus h plus 8. And then I have to work it out. So I'll have a negative 5 x plus h times x plus h. I'm going to distribute the plus 6 to x plus h. So plus 6x plus 6h plus 8. And then I usually wait to put any number in front until I get this. Remember, that's always what you get when you say x plus h times x plus h plus 6x plus 6h plus 8. And then finally, I'll take this negative 5 and distribute it in here. So negative 5 x squared minus 10 hx minus 5 h squared plus 6x plus 6h plus 8. Ow. Woo! And so this is what, let me make sure, yeah, I've got all my like terms together. Sometimes you do have like terms. Usually you have to go up to a cubic to do that. Now step 2 is find f of x plus h minus, okay, all right. Minus f of x. So that's going to be negative 5x squared minus 10hx minus 5h squared plus 6x plus 6h plus 8 minus parentheses that thing. Negative 5x squared plus 6x plus 8 okay, so that's going to be, I'll have to write smaller, minus 5x squared minus 10hx minus 5h squared plus 6x plus 6h plus 8. Distribute the minus sign there, there, and there, so that you'll have plus 5x squared minus 6x minus 8. And once the parentheses are gone, you can combine your like terms. And when everything goes perfectly, negative 5x squared and 5x squared will cancel. Negative 10hx, no. But 6x minus 6x, they don't cancel. They zero out. And then there's 8 minus 8, that's 0. And what we're left with is all of the terms that have h in them, which will be negative 10hx minus 5h squared plus 6h. And that is what f of x plus h minus f of x equals. The third step is just divide everything by h. So f of x plus h minus f of x over h is going to be negative 10hx. I'm just going to go ahead and put it, the h separately under each term, minus 5hh over h plus 6h. Yeah, and that came from there. Plus 6h over h. And now the h's cancel, the h's cancel, the h's cancel, and we now know that the difference quotient of negative 5x squared plus 6x plus 8 equals negative 10x minus 5h plus 6. And doesn't that feel good? I want to download attendance before everybody leaves. I don't care about that, whether you're here, whether you watch the video later at home. Well, of course, whether you watch the video later, but this is a boss thing. Okay. We have learned something that is so full of college algebra. Two things this week. You've learned about function arithmetic, which is also called function operations. And now you've done the difference quotient, and both of those are real live college algebra. No more non-transfer courses. This is the big deal right here. College algebra. Yes, it is. And so that's college algebra. You can stick around if you want to ask specific things, or you can go ahead and leave. These notes will be up in modules, and as soon as the video processes, it will be up in modules. So you'll be able to just keep enjoying today's experience. Wait until you see tomorrow. Right, okay, bye.
I have a question.
Okay, sure.
You said that the homework isn't due until Friday.
Yeah, Friday night, it's not gonna disappear.
Okay, but I tried accessing the homework for the first day for the 24th, and it won't let me.
I already heard that about the 25th, so I guess I have to go in and fix it. And I will, because it's definitely not just open for one day.
Okay.
I couldn't do that if I were a student. So I will reopen it.
Okay, thank you so much.
You're
Have a
welcome.
nice day.
I will, you too. Any other questions? Hey, I have no pressing social engagements except to feed my dog, and I'm sure she considers that a pressing social engagement.
Miss Rademacher, I was gonna request, can we do one more time, but really slow? I think I just get stuck in the parts in the so in the first step, I get stuck in the second line. Can we do another one?
Sure. How about and I'll go real slow. In fact, I'll wait for you to tell me to go on.
Okay.
F of x, let's make it equal something like 3x squared plus 2x minus 1. Okay?
Okay.
And that means that step 1 is going to be f of x plus h equals 3 times x plus h squared plus 2 times x plus h minus 1.
Okay, and then this is the formula. This is where I'm like, okay, I got this. Now, the second line is where I get confused.
That's right. Yes, the second line is very dangerous. So, 3. You've got to split this parentheses x plus h into 2, like this. X plus h times x plus h. Because when you square something, that means you multiply it by itself 2 times.
Okay, cool. I'm glad I got that one out of the way.
Good, good. Meanwhile, I'm going to distribute the 2x plus 2h minus 1.
Okay.
Okay, now I'm going to wait. I'm not going, I mean, I suppose I could multiply the 3 into that 3x and make it 3h, but I don't do that. I just think it's easier to get bracket, to get the x plus h times x plus h multiplied first. And so what that is if we were going to go real slow, you take the x from the first set of parentheses, this x right here, write it down, and then you bring in the second set of parentheses and write it down like that. And then you take the plus h from the first set of parentheses and you write it down.
So now, Miss Barbara, why do we do that?
It's one way of multiplying. We could also go x plus h times x plus h, FOIL, first, outside, inside, last. And so I would take the x and multiply it by the h for the first. Oh no, I would take the x and multiply it by the x for the first, because this is the first term of these two numbers, and this is the first term of these two numbers. I would have x times x, and then put a plus sign between them because there's always a plus sign. Outside would mean this x times that h, except I have to write it hx. And inside would mean h times x. Here, so we end up with this times this. Okay, so I have first, which is the x times x. And then outside, which is the x times h. And then inside, which is the h times x. And they're both written hx. And then last is the h times h. That's a much better known way of multiplying two binomials together.
Oh, okay.
Is that what you were asking about? Why do we do it one way and not the other?
Yeah, no, well, it's okay. I was just confused in one of the problems where we were doing the brackets, and then whenever you said put down the x and then take the plus h to the other side, I was like, wait, why are we doing that? But that's where I got confused. That's where you lost me. I was like, what do I do next?
Okay, yeah, so here we are down here doing it that way, which is called the distribution method. You take the x from the first set of parentheses and write it down. Then you take the whole second set of parentheses and put it beside it. Then you take the plus h and you take the second set of parentheses and put it beside it like that. And then copy down the rest. And now coming back here, you distribute the x and distribute the x. So you'll have x squared plus hx. And then you distribute the plus h into there and there. So plus hx plus h times h, which is h squared, plus 2x plus 2h minus 1. And then finally, we can finally take this 3 and just, well, we could, yeah, we could do it here. 3x squared plus 3hx plus 3hx plus 3h squared plus 2x plus 2h minus 1. And then we have one more step. So tell me when you're ready.
I'm ready.
Okay, I am going to say, okay, well, these hx's are both hx terms. I've got 3 and I add another 3, that means I've got 6. So 6hx. And that's these two guys added together. Plus 3h squared. Plus 2x plus 2h minus 1. And that long ugly thing is what f of x plus h is.
Okay, cool beans.
Yeah, I bet your hand's tired. Mine is. Number 2, now the next step is to take f of x plus h, and now we know what that is, it's this thing, and then subtract f of x, the original f of x. So we're going to have 3x squared plus 6hx plus 3h squared plus 2x plus 2h minus 1 minus, in parentheses, 3x squared plus 2x minus 1.
Now, where did we get the 3x squared plus 2x minus 1?
That's what f of x is. From way back here, f of x equals 3x squared plus 2x minus 1.
Beautiful. Okay, perfect.
Okay, once I can't add the like terms together if there are any. Well, there will be. Because of those parentheses. And the only way out of parentheses is to distribute the sign in front. So here and here and here. So that's going to give me 3x squared plus 6hx plus 3h squared plus 2x plus 2h minus 1 minus 3x squared minus 2x plus 1. Because I'm distributing this negative sign. And negative times negative is going to give me a plus.
Okay.
And then I combine my like terms. The 3x squared and minus 3x squared is 0. And the 2x minus 2x is 0. And the minus 1 plus 1 is 0. And so what I'm left with is this term right here.
Mm-hmm.
And this term right here. And this term right here. So f of x plus h minus f of x is going to equal 6hx plus 3h squared plus 2h.
Okay.
And step 3,
Mm-hmm.
we know what f of x plus h minus f of x is, and what we have to do is divide it by h, because that's what the difference quotient is.
Yes. Divide by h is the last step.
So I'll have 6hx over h, and then I come up here, plus 3h squared, but h squared can also be written as h times h.
Uh-huh.
And I just do that because it's easier to cancel. Plus 2h over h, because in each of these terms, the h on the bottom cancels out an h on top.
Mm-hmm.
Like that.
Cancel, cancel, cancel. Okay.
So that what's left is 6x plus 3h plus 2. And that's the answer.
Yay!
Yay!
Okay, cool. Alrighty, Miss Barbara. I think I sort of got it now. Yesterday I was having some difficulty with the first problems, but I'm gonna try again and see if I'm comfortable. Also, I don't know if you can check, but remember how last year you said that some of my work was incompleted? I wanted to make sure that it was complete this time and that I wasn't, because I think my mistake was that I was going into practice mode instead of doing the actual thing.
Ah,
So I wanted to make
yes.
sure that you are able to see that I did my work.
Okay,
Can you do me that favor?
I am going to write it down right now.
Yes, please. Alrighty, Miss Barbara. And I am so sorry. I'm going to head out because I have a class that started at 12, okay?
Oh no. Oh, go away. Go,
Alrighty.
go,
Have a
go,
nice
go.
day.
Bye-bye.
Bye.
Check Myra's work. We're going to do it. All right, we are ready to stop recording. If anyone is still here. Mitchell, you're still here. Can I help you? I can't hear you. And I can't unmute you. I can mute you, but I cannot unmute you. Okay, well, I'm going to stop recording and get ready to go, but you know how to get in touch with me and you know how to email me. So I will talk with you later. Bye-bye.